Okay, you asked him about time. When I started teaching, I was teaching in Pakistan. I used to teach in T-shirt and jeans. The weather is like this. Sometimes they have AC, sometimes no. Never had AC. Sometimes the fans were okay. So we were doing the topic of two-lane highways. Okay. How many classes? 3 classes. Okay. And we did a very long example for two-lane highways, but we only did one direction. I told you you can do the other direction. Just repeat the same process. You have to switch the volumes. Okay. And another thing which I mentioned that we did it only for class 1. And the good thing about class 1 is we got to do the calculations of ATS and PTSF both. Now for class 2, I will only do the calculations for what? PTSF. And for class 3, I will only do the calculations for what? ATS. Okay, but after calculating ATS, you have to do an extra step to find out the level of service. Because for class 3, level of service does not depend upon ATS. It depends upon what? PFFS, percent free flow speed. Okay, so this one is a ratio of ATS and free flow speed. Okay, so that's why you need to calculate ATS. Okay. Okay. Another thing is calculation of capacity for two-lane highways. What is the ideal capacity for two-lane highways? Anybody remembers? The ideal capacity, the best value for two-lane highways. 3,000. Okay, close enough. 3,200, but that is for both directions. Okay, and then for one direction, 1,700. Now this is ideal capacity. If you remember, I showed you a table in which ideal capacities were given even for multi-lane highways and freeways as well in the last chapter. So those are in ideal conditions. But the highway has its own conditions which we call as prevailing conditions. If you remember, there was the word appeared in the capacity definition, prevailing conditions. So what will be the capacity of the highway under the given conditions? It would have been 3,200 if the conditions were ideal. They are not ideal. Capacity will be calculated as this. And this will give you capacity of one direction. So ideal capacity is what? 1,700 for one direction. And then we multiply with 2 adjustment factors for what? These are factors for gradient and heavy vehicles. And both of them depend upon terrain. Both of them depend upon terrain, but their tables are different. FXB we calculate, and for that we need a factor, another factor which we see in some other tables, and FG we directly take it from a table. Okay. Now if I go back to the tables which I showed you for FG, okay, these are the tables. You can use this one, the previous one, or this one, depending upon the terrain conditions. Okay. But FG also depends upon the flow. In all these tables, we are using flow as well. Okay, so which FG value should I take? Because I am calculating capacity of the road. So what is my flow? 1,700. Okay. Somehow correct. Yeah. Any other idea?
Over 900. Over 900.
Over 900. Okay. capacity is defined as what? Definition of capacity is maximum flow rate, right? So whatever gives the maximum flow rate. Like I said, you are correct. But the logic behind is whatever gives the maximum. So I'll take the maximum, the value for the maximum flow rate for any condition. If I have rolling terrain, I take the value of Fg for rolling terrain for the maximum flow rate. If I have a gradient, I'll go to the gradient table. I'll take the value for that gradient for maximum flow rate. Got it? So in that table, in that column, whichever flow rate is maximum, I will take the Fg value for that. Okay? And FHV, we calculate, like we calculate. It has nothing to do with the flow rate. Okay. Class 1 2-lane rural highway segment, current traffic 400. Okay, and we have 15% trucks, 2% RVs. As we have been doing, we will combine them. Okay, directional distribution 60-40. Peak power factor 0.84. Class 1 400. Okay, 15 and 2%. Capacity of this facility, okay, and 8% per year. In how many years it will reach the capacity? Okay. Capacity of the facility means for both directions. Okay. And they say capacity of the facility, they mean total of both directions. We have the equation for capacity, right? They should have mentioned the killing. It's missing. Yeah. See. Okay, here it is missing, but we can assume something. Okay, so let us assume it's level. Terrain is level. It should have been given. So I need FHV and FG. For level terrain, this is 2. The FHV is
0.84.
okay. And then we need the capacity. So we will take 1000 and sorry, then we need FG as well. Now FG for level terrain is 1. For level terrain is 1. The entire column is 1. Because obviously this is the factor for gradient and you have no gradient, so the factor is 1. So capacity is 1700 multiplied by Fg and FHV. Fg is 1. So the capacity is how much?
144. 1.445.
Because why I'm writing passenger cars per hour in. Okay, it should not be passenger cars per hour. It should be vehicles. Okay, it should be vehicles per hour per lane. So why it is vehicles per hour per lane? Heavy vehicles are included. Okay, and what else? What were the units for this 1,700? What are the units here? They are passenger cars per hour per lane. So you multiply with FHP, it became vehicles per hour from passenger cars per hour. Okay, and then you multiply by FG, it doesn't change the units. Okay, but 1,700 itself is per lane, is for one direction. So the final answer is also per lane. Did I solve part 1? Part A. Is the capacity 1,445? Only for one direction. So what should I do? Multiply by 2. 60-40 distribution. Okay. Which one is this?
60.
60, right? The higher one. Okay. So what should I do to make it 100? I got the 60 of the total, right? How do I get the total?
Equals 60, 0.6. This answer equal x multiplied 0.6.
1445 equals
X
x.
multiplied 0.6.
So x will be the total capacity.
Yes.
How much?
2.408.
2408. Sorry. Okay. So this is for part A. The total is 2,408 total capacity. Now what should I do for part B?
The equation.
We have an equation, right? So from that equation, I am trying to calculate n. How many years? Okay. So the equation is right here. Okay, f equals the present value 1 plus I to the power n. I'm trying to find out n here. Okay, I is 8%. Present value is, you can see it, right? Present traffic, they are asking me when will the present traffic reach the capacity. Okay, so the present value is 400. Clear? Okay, capacity will not change, huh? You cannot apply the growth rate on capacity. Every year capacity will not increase. What is increasing? The present demand, the current demand. current demand, what is the current demand right now? 400. Okay, so they're asking me when will it reach capacity. So when will this 400 will become, yeah, but there's a small point here. This is 400 is volume and capacity is 400 is volume and capacity 2408 is what? What do we call this? Flow rate. So I cannot compare, I cannot put flow rate and volume in the same equation. Either I should convert the capacity into volume, or I should convert the current flow rate, current volume into flow rate. Okay, which one you want to do? Capacity to volume, huh? So how do we convert flow rate to volume? Tell me. To convert flow rate to volume, what should I do? We have done it earlier, last chapter. There was an example, the last example which we did for freebase. We converted flow rate to volume. Yeah, say. You were saying something. Multiply what? Yeah, multiply the flow rate with what factor? FG. FHV. Capacity adjustment factor. What? Multiply with what? 0.84, which is the peak hour factor. Flow rate into peak hour factor gives you volume. So you convert this into volume. Okay, so 2408 multiplied by the peak hour factor. How much is this? So the future value will be the capacity, which is 2408 multiplied by 0.84. How much? How much? 2020? Really? So next year I cannot do this problem, right? This much, huh? So next year I have to think about some new problem. Okay, now give me number of years. In how many years we will reach capacity? Current value 400, future value we just calculated, and I is 8%, so you put 0.08, and N you need. Okay, so this is in years because the growth rate is per year, so you calculate number of years. And why did they ask me to do it? Again, I gave the reason in the last chapter as well. Why should we know when the facility will reach capacity? They can start planning from now. Okay. Any questions? Clear? Everything is clear? Okay. Okay, so I have uploaded the form where you can pick which topic you don't want in the final exam. Pick wisely. Okay. I know there are some people they start, they start this message campaign. Select this, select this, select this. Okay. And then everybody says, oh, fine. We will do for this. We'll go for this. I will tell you what happened. In one of the previous exams, last semester or before, I don't remember. So they selected one topic, I excluded it. Then a question came from some other topic. They said, doctor, this is what we excluded. But they didn't see the same question or the same topic was used in some other lecture as well. Get my point? So I excluded the topic, and still I gave the question. Magic. Okay. Now we'll talk about traffic control devices. Whatever time we have left, I think we will just cover the theory. Okay. But we have my word, even if we do some small problems, I will not do it in the final exam. Okay. Just improve theory problem. Okay. What?
Maybe they want to exclude this chapter.
It's only from 1 to 6. Topic we already covered. Why would I give this? Okay, so this topic is about traffic control devices. So there are more than two chapters in your textbook about traffic control devices. These lectures contain 2 of them, chapter 4 and chapter 28. If you go to the textbook, somehow, miraculously, you will see that there are separate topics about roundabouts and signals and so on. Okay? Anyways. So what is a traffic control device? Traffic control device means any medium through which a traffic engineer can communicate with the driver. Okay, so WhatsApp, Instagram, TikTok, all these things are not included. Okay, they are not included. There are 3 types of traffic control devices. We have traffic markings, traffic signs, and traffic signals. Okay, these are the 3 main categories. Then in each one of them, we have subcategories as well. We will talk about them. The standards for designing the traffic control devices are given in a manual, which is called as Manual on Uniform Traffic Control Devices. You can see the short form on the top, and the full form is in the first bullet point. Manual on Uniform Traffic Control Devices. So this manual only contains the standards about traffic control devices. Okay. So what type of standards we are covering in the manual, or we should know about traffic control devices? The application of traffic control device. In which situation, which device can be used. So an engineer cannot randomly say that I will put signal on this intersection, I will put roundabout here. There are some standards which you have to follow. Then what should be the design of the device? Okay, the design and placement. Where would I put the device? If I am designing a signal, where should I put the signal? If I am designing a sign, if I am going for a sign, where should I put the sign? Middle of the road, side of the road, higher, lower. So all these standards should be known or should be taken into account when you are designing traffic control devices. So this particular manual is published by FHWA, Federal Highway Administration. I haven't seen any update after 2012. I may be saying that why are we still using this manual when the technology has progressed so much? So now we have new types of signs and we have new types of signals. After 2012, 11 years, a lot of changes have been made. Okay, now we have sensors and all. But where should I use the signal? The design of the signal, and where should I put the signal? These standards have not changed. We are still using the same 3 lights. You still see the signal. There are some specific places where you put the signal. Even if the signal is of a new, of a new technology, it is connected with a sensor, it is operating by itself, it doesn't matter. That these things will remain the same, whatever type of signal you are using. Now we have electronic signs. So where should I use which sign? I will use same sign. Okay, I will not put the board. I will not put the steel sign there with the static sign. I will put an electronic sign which changes. But still, where should I put the sign? What colors will I use? Same sign. Okay. And yeah, why do we need standards for traffic control devices? So that we have uniformity, consistency, similarity in their use, placement, and design. So now we have international driving licenses. Okay, so this started basically in US, and still they have a lot of changes from one state to the other. So from one US state to the other, there are a lot of changes. Okay, in traffic regulations. So obviously, one country, so drivers are moving around from one place to the other. So they were facing problems. They came up with a solution. Okay, let us make one manual which will be followed by everybody. So if it is good for a huge state, a huge country like US, which has a lot of variations in terrain and climate and so on, so other people also adopt it. Okay, so this is the reason. Okay, so in this manual, they are covering the standards for design of the device. Design means what? The shape of the device, size, colors, what legend you will use on the device. Legend meaning what? What is the legend? What is the legend? Somebody is very old, right? He died protecting his country. What is the legend? Icon, symbol, something like this. Okay. So, what type of legend you are using? Okay, symbols and these things. The size, the font size of the legend itself, the design of the specific legend, and so on. And it also contains standards and guidelines on where you should put the device with respect to the road. From the road, how far or how near should the device. And the warrants and conditions. Okay, so like I mentioned earlier, in which condition, which device should be used. So the manual contains the standards about all these things, and these are the things we should also consider whenever you are designing a device. Okay. An effective traffic control device should have these components. An effective traffic control device should have, or it has these requirements to be an effective control device. If you are not fulfilling these points, your control device is not effective. Okay, it should fulfill a need. So, for example, you see traffic signs for speed limits. We use them where we need them. So you will not see a speed limit sign beside a signal. It's not required there. Signal itself tells the driver when to move and when to stop. Okay, so you don't need to put an extra condition on the driver when you will be moving. Your speed should be this much. Okay, so we will put the speed limit sign where we feel the driver may overspeed. It could be dangerous. Then we put it there. Okay, you may see those orange cones which they put where. Where do they put these orange cones on the road?
Intersection without signal. Intersection without signal.
Intersection without signal. Okay.
Maintenance.
If they have some maintenance activity going on, so again, you can only use them there. You cannot come up. Okay, I will put it here because this road looks dangerous or there's a pothole or something. No. Okay. So each device should be put where it is needed. Not needed, we will not put it. Okay. It should command attention of the driver. It should be so prominent. It should be so clear. It should be in a language which the driver understands. So it immediately catches the attention because something which he can see and understand very easily. Okay. So you have, and then we have convey a clear and simple message. We keep the message as short as possible because the driver doesn't have much time. Okay, so you may have seen signs on which they write construction work ahead. That's it. What to do? You decide. Okay. You want to go in this lane or this lane? You reduce your speed. Okay. The main aspect is, okay, driver should be aware there is construction work going on, and that's it. The most obvious example is markings on the road. All road markings are just lines, nothing else. Okay. They are just lines. They are just using different design of lines or different colors to convey different messages. Okay, solid line, dashed line, yellow line, white line, black line. They are there, you cannot see them. Okay. Command respect of the road users. Now, commanding respect means what? The driver should, when the driver sees the sign, he should stop the vehicle, come out, do a salute, and then. Huh? Okay. Commanding respect means the driver should know the importance of the sign. He should feel, if I don't follow this, there will be something dangerous for me. Okay. Or I will have some sort of loss. Okay. So, for example, there is a sign or there is a marking which says this lane for left turning. Okay. And the driver can see I am coming towards an intersection. Now what will happen if you are not in that lane? You want to take a left turn, or let's say you don't want to take a left turn but you are still in that lane. What will happen? You have to change lane, but then it is. If you are in the wrong lane, then you may not have the chance. The other lanes may be too full, you may not have the chance to change the lanes. Even if you try, then you may cause accident or traffic jam. The driver has to stop for you. So you can see the need. I have to be in my lane, otherwise it will be dangerous and so on. I will waste my time and others' time and so on. Got it? Okay. You see pedestrian crossing, so they use these speed humps there. Okay, for pedestrian crossing. So I can see that there is a speed hump. Okay, and I can see that it's a pedestrian crossing. So I feel the need, I should reduce my speed. Okay, got it? Yeah. So every device, this is how you command the respect of the road users. But it is directly linked with one of the previous points. Which one? This one is directly linked with one of the previous 3 points. Which one? Attention. A sign clearly says this way to Mohalla. So what? I saw the sign, fine. Do I feel the need to obey? No. That's it. She made it very easy for us. Okay, it's the first one. Okay, good. Okay, it's the first one. You put a sign where it is needed. Put the sign, not the sign, the device. You put the device where it is needed. Okay. So if I see the need, I know how to follow it. Okay, I can give you the example of the lane marking. for the pedestrian crossing. You put the speed hump where there was a pedestrian crossing, so I can see it, and I know I have to reduce my speed. I know. Okay. Otherwise, it will be dangerous. I'm at an intersection, so I need basically even if I don't see it, I'll be looking for it. In which lane should I go? Get my point? Okay. So if there was a need, and then you fulfill that need with a traffic control device, eventually the driver is looking for your advice basically. At that point, the driver is looking for your advice. What should I do? Because there's already a need. Okay. Have you observed yourselves when you are on a highway? Okay. You don't see any intersections and it's a long, clear highway, wide road, and you are speeding. After some time, you will yourself feel the need. Okay, I should be looking for somewhere for the speed limit. Maybe I'm overspeeding. I don't know. Okay, because you know there's a law, there can be cameras. So you, even if you missed it, now you have in the back of your mind that at this location maybe I'm overspeeding. Okay, so this is what they are saying. And the last one, we already talked about it. Give adequate time for proper response. How do we do it? How do we give a proper response time? Perception reaction time, and we use perception reaction time to calculate what? Sight distance. Okay, so sight distance should be enough. The sight distance is enough, then you have the proper response time. So signal, on a signal, you have the sight distance for stopping. So I need, for example, 50 meters to stop at the speed of the road. I need 50 meters to stop. So if I can see the signal from 50 meters, it's safe for me. I will stop. But if I can only see the signal from 10 meters, even if I try, I cannot stop. Okay. Same thing with pedestrian crossing. Same thing with everything. So the last point is mainly linked with the sight distance. You have enough sight distance, you have proper response time. Clear? Okay. The communication with the driver should be clear and as per standard with redundancy. Okay. Clear and standard we already talked about. Okay. Now what do we mean by redundancy? There are redundant members in trusses. Yeah. Multiple times. Basically multiple times. Yeah. But redundancy basically means you are doing something which may not be required. So this is something extra. Redundancy means something extra. So every driver does not need the repetition. Most of the drivers do not need the message to be repeated. But we do it for the purpose of safety. Now how do we do it? We do it through the design of the device. Okay. So for example, a sign with a red color, we usually to slow down or to stop. So even if I don't see the number or word on the sign, it is catching my attention. There is something to be cautious about, and I should not speed now. I should probably reduce my speed. Okay, so the color, even without any number or the word is telling you, miss the number, you will not read it properly, but you know it's something related to slowing down or something related to a danger. Okay, and so on. Even the design of the signal. Okay, so which light we have on the top? Right, so always red. Red on the top, then yellow, then always. So this order is telling me, order is conveying the same thing. The top light means red. In some cases, maybe you are behind a truck or something, you can only see the top light. It goes off, I know. Now the next one is green, it's yellow and red. That's my point? So yeah, yellow and green, sorry. Yellow and green, yeah. But good idea, right? Okay. Another way of redundancy is that you convey the message. So you have the design of the device which is conveying the message more than once. The same device conveying the message more than once. Then you can use multiple devices to convey the message. Okay. So you have the signal itself, and sometime before the signal you have a sign. Signal after 200 meters. Same message, right? Same message. Okay. And then on some cases you have the marking, the arrow sign on the pavement, and then you have a board as well. You know, 2 lanes to go left, 1 lane to go straight and so on. So different devices for the same message. This can also be done. Okay. Types of devices. We have 3 types of devices: traffic markings and what else? Signals and markings, signals, signs. Okay. Traffic markings are the most commonly used devices. So they are more common than any other. You will not see traffic signs or signals maybe on all locations, but at all locations, maybe 95% of the locations, there must be some marking there. Okay, so they are the most commonly used, plentiful used devices, and these can be divided into 3 categories. We have longitudinal, we have transverse, and we have object markers and delineators. Longitudinal means if I say something is longitudinal, it is along, it is parallel to the length of the road. Okay. So which markings are parallel to the road? What? Give me a.
The white one.
And these are for dividing the lanes. Okay, what else? Any other example for longitudinal marking? Shoulder. In some cases, the median is also marked. Okay, with a white line. You get that. Transverse is something which is done across the road at any angle from the length. It may not be 90, but it's transverse. Okay. Give me a couple of examples.
Cross sections.
What do you mean?
The name in the cross section.
In the process. Anyone else? Or transverse marking, yeah. What do you mean? A marking which is across the road, which one? Pedestrian crossing, okay, what else? Anything else? Something we have before pedestrian crossing. That is also transverse. So these are the lines of pedestrian crossing. Just before that, we have another line. Or zigzag is for the pedestrian, right? And before that, we have sometimes a stop line. Okay. The stop line is also transverse. Parking markings, if you are parking beside the road, also transverse. Many cases. Okay. Then we have object markers and delineators. These are the object markers and delineators. Okay. So object marker, the top one. Okay. This thing. This one. Okay. This one is an object marker. Okay. It's an object marker. And these small orange bars, orange and white bars, are delineators. Okay. So object markers are used to tell you that now you have to change your direction. You cannot continue. Okay. This is the end of the lane for you, end of the road for you. Now from this point onwards, you have to go right or left. There is no straight for you. Okay. So in some cases, like you can see in this picture, they are vertical. Vertical means now change your lane. Okay. So I took this picture in front of the Indian school near the traffic island for left turning. So if you are coming straight, you see this, either go here on the right hand side if you want to go straight, or go towards the left hand side if you want to go left. Okay, but sometimes we have them in horizontal position. Okay, when you have a three-leg intersection, a three-leg intersection or three-way intersection, three-way junction. So you are coming now, and this is a dead end now. Cannot go straight. Okay, you have to take a right turn or left turn. So in that case, they make it horizontal. Okay, so object markers are basically telling you the end of the way, end of the road. Okay, they are asking you to divert now. And delineators are just before the markers. Delineators are just before the markers. They tell you the space from which you now have to divert. So you will see these delineators near the ramps as well. So there is a ramp now, and I have to tell the driver from this point onwards, change your lane. You cannot continue now. Okay, so delineators are now diverting the driver to a specific direction. So object markers is like a warning sign, and delineators are like for guidance. Okay, so from which point I cannot continue? I see the delineator. Okay, so I see from this I have to follow this line. I have to follow the delineators. Got it? Now, why are we discussing them in traffic markings? They are not markings. Are there markings on the ground? No. We can include them in signs. They are definitely not signals. We can include them in signs, but we are not including them because of their design and size. Okay, they are somewhere in between. The marking obviously is on the ground, right? And signs are usually more than 4 feet above the ground. They have less. So we had to include them in one or the other. So they decided to put them in marking. Okay. So because of their size, signs, traffic signs are usually higher, bigger. Okay. Okay. Any questions? There. Okay. Thank you.
About the project, I finished the breakfast and the
You finished the calculations?
The calculation finished only about the application. Application, I asked my friend who said he did the application already.
You download it?
I downloaded. Oh, I will.
Yeah. Do it with one of them who are already doing it. Do it with one of them. Hi. You called me, right? Somebody called me from this number at 2 o'clock about the innovation camp for 21st May. Yes. Yes. You said 31st, right? 31st. So that's from 8 to 1. Yeah, sure. So you will, I remember they used to do like orientation session and this. They will do it. Yeah, if it is the same, because I did two now, I think I can manage. Yes, yes. Yeah, sure. But it's the same procedure, everything is the same. Yeah. Yes, yes. One more thing, maybe it's not related to, the last event, which I attended with the University of Michigan, they used to have a certificate. I didn't get it yet. It was before March. March. It was like on 2 days. Um, yeah, I think it comes on your app, right? With an app. Should I do anything with the app now? Sure, sure. Sure. Yeah.
Victor, for the presentation, control time.
Today is what? What?
Then after the presentation,
28, inshallah.
يوم الأحد. يوم الأحد.
No, if you want to do it later, I don't mind. But it will be getting closer to your exams.
Victor, about the project, or Victor does we want to make a structure.
What is the answer?
So we will do it with another. No problem. Okay, Victor.
So if you want to do it and then you say no to do it, you have to. Yeah, sure, sure. Did you talk to someone? Talk to someone, maybe we want, we can include his or her name from the start as a co. It will be, if they agree, so it will be good for them as well. They will already have a group. So because they will announce the topics, maybe that person, after he has his own groups, he may say, no, no, I already have 4 groups. Like, theory from 7 on, lecture 7 on.
Thursday we will finish. Whatever we covered. Okay, but I said from this, even if we go to some numerical, if we do it, just for the sake of the class. Final exam, I will not include numerical. You cancel it. Yes. You don't study from it.
No.
Who told you have to study about all the time? One guy told me, he wants to study. I didn't used to study at all. He is a famous guy in Pakistan. He said his own team. He said, I didn't used to study at all. I was not a good student. So before the exam, final exam, pray to the God. They make prayer. Whatever is coming in the exam tomorrow, just type in that. Okay. Then I open the book, and from whichever page it will open, I will only study that. And according to him, because of my prayer, only from that part it came in there. You want to try?
No.
And tell me if it works on. Inshallah, I am not worried about you. A good student. Okay, be confident. Okay, and at the time of exam, just relax. You guys lose more marks because you are thinking what to do. Okay, you know what to do, then you get my do nothing. Okay, but not with you. How many? 9. Why are you asking? Look. You should be telling me, doctor, include everything from the mission. Right?
Yes.
It's good for you, right?
Thank you.